Geometry Unit 1, Lesson 1, Build It. Our goal or our learning target for today is to be able to accurately and precisely use our tools to create geometric constructions. So to start out with, in task 1, it says copy this figure using only the pen tool and no other tools. So I'm going to use the pen tool, and then I'm going to do my best to recreate, kind of looks like a Venn diagram to me, the two circles with the segment PQ connecting them. All right, so here's my first circle. It's okay. Let's see, it looks like there's a point in the middle, and I'm going to call that point P. Ooh, okay. And then it says there's another circle. Okay, not great. Here's the middle point. I'm going to call that Q. And then there's a straight line connecting P to Q. All right, so it's not great, but it's probably about as good as I'm going to be able to do just using the pen tool and no other tools. So moving on to task 2. This one is just asking you to play around with your digital straight edge and your compass tools. So my digital straight edge, that means I'm using things that are going to give me straight lines. So here's my line tool. It's going to ask me to pick 2 points, and you can see where I place that second point is going to determine which way that line is headed. It's a line, it's going all the way across the grid because we know lines extend forever in both directions. All right, this one here, this tool, is just the segment tool. Notice when I click on it, the instructions pop up down here. So this one says select 2 points or positions. So I'm going to make a segment here. Maybe I'll connect it back to point B. So I have a line AB and then a segment CB. And then I also have a ray. So if I want to create a ray, we're going to select a starting point and then a point that's on the ray somewhere. A ray only goes in one direction forever, right? So those are my straight edge tools that I can use. You just play around with those as you need to. When it talks about our compass tools, those are going to be the ones that are going to help us create circles. So I'm going to just look at my first circle tool right here, my compass tool. When I click on it, it says circle with a center through a point. Select a center point, then a point on the circle. So this is kind of like the compass that we're using in class. I'm going to select a point C, and that's going to be like the center of my circle. And you can see as I drag my cursor out, my circle is getting wider. Okay, now where I put that other point, F, C, F is like the radius for that circle, right? Okay, and then here's my next circle. This one's centered at F, and I'm just going to try to make some circles of different sizes here. All right, I think I've got the hang of that one, so I'm going to try my other compass tool. This one is actually called the compass. Select a segment or 2 points for a radius and then a center point. So we're selecting which segment we want to use as our radius. So let's do segment CB. Okay, that'll be our radius. And then see how it's following me around. Wherever I click next is going to be the center. So I'm just going to let the center of my circle here be at B. Okay, so I'm going to try one more of those, I think. This time I'm going to select F to G, okay, and then see that's the distance that is my radius there. And I'm going to let the center this time, let's put the center on C. All right, so I've kind of familiarized myself with the tools there. I know that's a little bit of a mess on that screen, but I'm just going to leave it because we were just using that to play around. All right, task 3. Copy the figure by completing these steps with the line, segment, and ray tools and the circle and compass tools. So the ones that we were just messing around with up here on task 2. Okay, so our instructions, our steps that it's talking about here are down here underneath our workspace. So our first step, draw a point and label it A. So this is where we're copying this figure, right? It just says to draw a point. I'm going to click on my point tool. I'm going to create a point right here, and it has labeled it A for me. Okay, next step. Draw a circle centered at point A with a radius equal to length PQ. Okay, so I am going to use my compass tool because it's going to let me select the radius PQ. And now I have a circle, right, that is the same size as my original circles, and it says we want the center to be at point A, right? So I'm going to click on point A, and now I've got my circle centered at point A that has the same radius as this segment PQ right here. Okay, now it says mark a point on the circle and label it point B. So I'm just going to come back over here to my point tool. I'm going to click on my circle, and it's labeled that point B for me. The next step, draw another circle centered at point B that goes through point A. So I'm just going to use my circle with a center through a point tool. I'm going to select B because that's the center point. And I'm going to click on A because it says that's going to be a point that's on that circle. And notice these two circles that I've created are the same size as each other. They're also the same size as the original circles that we were trying to duplicate. Okay, so then our last step, draw a line segment between points A and B. So I'm going to come back up here to my segment tool, and then I'm just going to click on A and then B to construct my segment. Okay, so I now have a copy, an exact copy of my original tools. Okay, so that was task 3. Okay, on task 4. All right, so task 4, I'm just going to type kind of what I've just talked about. So I'm going to say that segment AB is congruent to segment PQ. That means because it is the radius for circle A and also for circle B. The two circles are congruent to each other and to the original circles P and Q. Okay, moving on to our next task. This one, again, our instructions, our steps that we're going to follow are down here beneath our workspace. This one says create a circle centered at A with a radius of AB. So here is my segment AB. I'm going to use my it doesn't really matter too much which one of these I use. I'm just going to use my circle with the center through a point. We want the center to be A, so I'm going to select the center point, and then we want the radius to go all the way to B. Okay, so we can see that's kind of a big circle. It's gone off of our screen a little bit. That's going to be okay. Next step says estimate the midpoint of segment AB, mark it with the point on object tool, and label it C. Okay, so our points on an object tool is going to be this one right here. I'm going to mark approximately, because it says estimate, where I think the midpoint of segment AB is. See, I'm going to select that. That looks like it's pretty close to me. And there's our point C, right? The midpoint of AB. The next step says create a circle centered at B with a radius of BC. Okay, so if I'm going to use a circle centered at B, right? If I'm using my circle with a center through a point tool, I'm going to click on point B. And this time the radius is only going to go to C, right? Because the radius is BC for this step. So notice that circle has a radius length that's about half of our original circle, the first one that we did. All right, it says mark the two intersection points with the intersection tool. So this is talking about where our big circle and our small circle are intersecting each other, okay? I can see the intersection tool is this one right here. I'm going to click on that one, and we're going to label, it says the intersection points. The one towards the top of the page, it says we're going to label D, so I'm going to click on that one. There's point D. The one towards the bottom, we're going to label as E, so then I'm going to click on that one. All right, so I've got my point D and my point E. Lastly, use the polygon tool to connect points A, D, and E to make triangle ADE. So my polygon tool is this last one here. One that looks like a little triangle, right? I'm going to click on it. It says select all vertices, then the first vertex again. So it says we want to connect points A. So I'm going to click on A, D, I'm going to click on D, E, and click on E, and then back to A because that was the first point, right? So here is my triangle. ADE. All right, so in class, I had everybody trace their triangle then onto some tracing paper and kind of compare with the people around them. What we figured out was that not everybody had the exact same triangle. And so when we started looking at which parts of our construction steps are going to let us end up with different triangles, we kind of figured out that the estimating of the midpoint, right? If I estimate where that point C is, if I estimate mine a little bit too far to the left or a little bit too far to the right, that's going to change the way my triangle is going to look. So all of these other points on here, point A, notice I can't drag it around. B, I can't drag it around, right? These other points are pretty fixed. They're going to be kind of in the same place for all of us. But when I click on C, if I estimated C to be a little bit too far, see to the left over here, look, it's making my triangle turn more into an obtuse triangle. But if I estimated point C to be a little bit too far to the right, then you can see it's turning into more of an acute triangle there. So where we estimate is going to make a difference in what our final product is going to look like there, okay? And you can see that shifting the other points around. Now, that's actually what we would call an illegal construction move. We don't want to do estimations, okay? Remember, our goal for today was to look for precise constructions. So I'm going to, where it says type your answer, on this next task, I'm going to put that estimation can cause diagrams to be inaccurate or not precise. We always want to be able to identify exact locations. We don't ever want to use estimations. All right, moving on to our next task. We see we have a hexagon here. This is a regular hexagon because all 6 sides are the same length as each other. That means all 6 angles on the inside there are going to be the same angle measure. So when that happens with triangles, we say they're equilateral triangles. When it's other polygons like this, we say they are regular. So this is a regular hexagon. Okay, so it's asking us to draw a copy of the hexagon using only the pen tool. We're going to draw our copy next to the one that's provided here, and then we're supposed to drag the given one onto ours. So I'm going to do my best here. Ooh, already off to a not so great start. Just using the pen tool, trying to make a copy of that hexagon. All right, I don't even really need to drag that blue one over on top of it. But when I do, I can see, oh yeah, that was a pretty inaccurate duplicate, right? So what happened, it was not an exact copy, right? Not even close. All right, moving on. Coming on down to this next one here. Here's a figure that shows the first few steps to constructing the regular hexagon. We want to use our straight edge and compass moves to see if we can finish constructing that regular hexagon. And then we can drag this one on top of it to see, kind of verify that we actually did create a good copy, right? Not like this one that I freehanded up here. All right, so I can see here that these 2 circles are the same size as each other, right? And that's got to do with the fact that they both have the same radius. So I know that I am coming up with equal side lengths so long as I keep using circles that have that same radius length. Okay, so I'm going to continue to build circles onto this diagram. I'm going to keep my radius the same length as these 2 circles, and hopefully, eventually, I'll start seeing my hexagons start to form. All right, so this time I'm going to put the center, I think I'm going to put the center here where my 2 circles intersect each other, and keeping that radius the same length. That's going to create some other intersection points for me, right? So I'm going to use my intersection tool. I'm going to put some points there. It's going to label those points. The names don't really matter too much, right? So I got my point D and a point E. I think I'm going to go this way, and I'm going to work off of point D. So now I'm just going to build myself another circle there. This time it's going to be centered at D. And then I want to keep that radius the same length. All right. There's another intersection point here. I'm going to label this one. There's our point F. I'm going to create another circle centered at F, has the same radius as the other circles. And I'm just going to keep on doing that same kind of thing until I get all the way around my circle. Label the intersection points, and then build the congruent circles. All right, and it kind of starts to create what, to me, looks like a little bit of a flower here in the middle, right? I think I'm close to finished. I just need one more circle here on H. Okay, and notice this flower that I have right here has got 6 what I would call leaves right around the flower. I was looking to build a hexagon, right, which has 6 sides to it. It's made up of 6 points. So I think if I use my segment tool now, I can, starting with my green line right here, continue connecting those points. So now I'm connecting D to F, connect F to G, G to H, and then H back to the original point. And I believe this figure is going to be my hexagon. So then to check, whoop, let me change tools there. I'm going to click on the move tool, so just the little arrow. I can drag my hexagon on top, and I did, in fact, end up with an exact replica, right? I know it's congruent because it maps right onto itself. Everything lines up. Okay, so then how do you know each of the sides of the shape are the same length? Show or explain your reasoning. Well, that's just what I was talking about there at the beginning with all of these circles having a congruent radius means that all 6 sides of this hexagon, we know for a fact, have to be congruent. So I'm just going to take a minute to type that out. All right. And finally, why does the construction end up where it started? That is, how do we know the central angles go to exactly 360 degrees around? Well, if you'll notice this flower, right, or this hexagon here, whichever one you're seeing, that's centered inside of one circle. And if I start at this point right here, right, when I connect to each of my other points, they're all along the edge of the same circle. And I do get back to where I started from there. So it's really got to do with the fact that because the hexagon is inscribed, right, that just means inside of a circle, and a circle is 360 degrees, the construction must end up where it started.